I decided I wasn't busy enough, so I redid the 5-4 notes recently for you guys. Just trying to chunk it into different parts so you can see that there's three main parts to the 5-4 dividing polynomials. Part 1, we're going to discuss long division, which you should have done in Algebra 1, versus synthetic division, which is only taught in Algebra 2, but long division is also an Algebra 2 topic, so we need to make sure we review it. Then part 2 goes along with part 1. It's about checking to see if something's a factor. Let's just put this here. If it is a factor, the remainder is 0. So just kind of like indicate that for yourself. And then evaluating polynomials, there's two ways. There's the old school plug and chug method, and then there's something new called the remainder theorem. And the remainder theorem is just the remainder you get from synthetic division. So let's talk about part 1, long division versus synthetic division. Now, in my history of teaching, I've known maybe 2 or 3 kids who prefer long division over synthetic division. I have one of each here for you if you want to pause the video and look at them. Again, synthetic division just overall is a little bit easier. But like I said, long division is part of the curriculum, so I am going to teach it to you. So we have one problem. We are going to divide the following by long division and synthetic division. And our answer, we're going to state the quotient and the remainder. So here's the problem. Let's set up long division. Now, long division is the same it always has been. You put what you're dividing by over here. And then you put what you're going to be going into here. If there was an x squared, but there was no x term, you would have to put a 0 there. If there was no constant at the back, you would have to put a 0 there. So you do have to make sure that your exponents are decreasing by 1. Otherwise, you need to put a 0 in. So long division does this, just like it would in with numbers. You focus on the 2x and right now the 4x squared. What is 4x squared divided by 2x? Well, the answer would be 2x. Another way of thinking about that is what do you need to multiply by? So what do you need to multiply 2x by? Whoops. What do you need to multiply 2x by in order to get 4x squared? So the answer would be 2x. So what do you need, or what is 4x squared divided by 2x? And that answer goes right here. I'm going to delete these underlines. Maybe. Okay. And now you backwards distribute. So I'm going to try to keep my colors pretty consistent for you here today. So you're going to do 2x times 2x to get 4x squared. These should always match. And then you're going to do 2x plus 5 to get a 10. Now, this is very important. I'm going to erase these lines because I'm going to have to draw new ones in when I do this again. It is time for us to put those together, but you must subtract. So you need to change the signs. That way, 4x squared cancels with minus 4x squared, and 20 minus 10x is 10x. Bring down the negative 16. Now we're going to do this again. I'm going to change back to green. We need to focus with 10x and 2x. What is 10x divided by 2x? Well, the answer is a positive 5. So we need a positive 5. Now, why do we need a positive 5? Let me show you. Let me erase here because we're going to need those there later. I need to backwards distribute. So I need, and you need this 2x to become a 10x. That's why we're using that 5. 2x times 5 makes 10x. So that's another way of thinking about it. Okay, so now it's time for me to backwards distribute. That I did in blue, so I'm going to stay consistent. So I'll do positive 5 times 2x is positive 10x. Positive 5 times 5 is 25. And now I'm going to erase those lines so I don't get too confused about stuff. Change to purple or pink, whatever color you think that is. And remember, this is very important and it's easy to forget. Change your signs. So if you have a negative, change it to a positive. If you have a positive, change it to a negative. And now add those things together. So the 10x's cancel, positive 10 minus 10. And negative 16 minus 25 is negative 41. See how there's no more x here? That means you've come to the remainder. If this was a 0, it would be a perfect factor. But this is not. This is just a remainder. So our answer is, so they asked for the quotient, 2x plus 5 from up above, and the remainder, negative 41. So our answer is 2x plus 5 with a remainder of negative 41. Now, that's long division, which is not the preferred method by most students. Let me show you synthetic division. Synthetic division will go much quicker. So what we do is we look at what we're dividing by, 2x plus 5, we set it equal to 0, and we solve for x. So it is important that you're able to solve for x because it's what you're dividing by. Watch synthetic division. You can follow this box up here if you want to, but synthetic division is really neat. You draw a little box to hold on to that negative 5/2 that we got right here. And then you put the coefficients, I'm going to highlight them in green. You put the coefficients of x squared, of x, and your constant up here. Now, if you're missing like an x, you would have to put a 0 in. Or if you're missing like a constant, you have to put a 0 in. So if you're missing something, you do have to put a 0 in there. So let's see. It started with x squared. So we'll do 4. That's from x squared. 20. That's from x. Negative 16. That's our constant. So if you had an x cubed, you would have to put more things down. But we just had an x squared. Draw a straight line. Now watch me solve synthetic. You drop down the first number. That wasn't hard, right? And you multiply these two numbers. So negative 5 over 2 times 4 is negative 20 over 2, which is negative 10. That answer goes here. So you multiply these two. Multiply these two. And that's where I put negative 10. Then you add going down. So 20 with negative 10 is positive 10. And then you take this positive 10 and multiply it with negative 5/2. So we multiply it. So negative 5/2 times positive 10 is negative 50 over 2, or negative 25. Then you add these together and you get negative 41. That last number is always your remainder, which is the exact same thing we got when we did long division. So I'm just going to make this a little bit smaller so that I can write my final answer here. Sorry, you guys might need to do the same thing. Sorry, I had to cut out at the end of this problem. I had a class I had to get to. But what I was in the middle of saying is this back number is always your remainder. So we can just do like remainder of negative 41, which if you notice that matches the remainder from when we did long division. This 10 here, or whatever it might be right next to your remainder, it's always your constant. And last, this number, they just build up. So this would be your linear term. In other words, it would get an x. If there was another number, it would get an x squared. If there was another number, it would get an x cubed. Now, you might say, Miss Langeli, that doesn't match at all. Like those two look like two totally different answers. The reason being is because of this negative 5/2. So let me encourage you that if you had negative 5/2 as an answer, it would have come from x plus 5/2. And then we would have multiplied that by 4x plus 10 to have our remainder of negative 41. So I promise in the long run, it ends up working out because like over here, this one would have been, let me make this one smaller so I can compare better for you. So this one, if you would have wrote it out, it would have been this 2x plus 5 And that's pretty darn equivalent to this one right here, right? Because they would both equal negative 5/2. So it would have been this 2x plus 5 with this 2x plus 5 with your remainder of negative 41. And if you wanted to go through the process of distributing these together, you would get the exact same product as if you distributed these together. So in the long run, I don't know if you like timed the video or not, but synthetic division definitely was a lot faster overall than long division.